Okay, and welcome. So this is a little task on the seven bridges of Königsberg. So let's jump straight in. You may have seen this thing before. Okay, so often this is like a little challenge. You might play it with your friends. Can you draw this shape following some rules? So here's the rules. Okay, you've got to start with your pen on the paper. You've got to draw the shape without ever taking your pen off the paper. And you're not allowed to go over any lines that you've already drawn before. Okay, so you're not allowed to retrace your steps. So this bit here, you're allowed to cross lines over, but what you're not allowed to do is retrace any of your steps. So for example, if someone tried this, oh, I'm stuck. So now I can't actually finish the shape because I either have to retrace my steps, which is not allowed, or I'd have to draw some sort of extra line, which is not allowed. Okay, so this is the game. Can you draw this shape in one go without removing your pen from the paper and without retracing your steps? So I hope you're clear on the name of the game here. And we call this traversing. So we say that you can traverse a picture if you can actually do this. So some pictures would be impossible to draw with this rule. But this picture is traversable. I am able to draw it following the rules of the game. Now, all this comes from a famous problem called the Seven Bridges of Königsberg. So, this is Königsberg. Okay, this is an old map of Königsberg, and these are the bridges. So, you can see the river, you can see it's got these seven bridges. And our friend, who we'll call Euler, is here, and he's thinking, can he go for a little walk that involves crossing all of the bridges once and only once? So, for example, he's going to go for a walk. It's going to go like this. Maybe it'll go that way. Maybe it'll come around here. It comes through here. Ah, so it's not worked because he can either take this bridge, but now he's stuck, you see? He only wants to take each bridge once. And again, if he'd gone the other way, he would have been stuck over here. So we might try it again. Okay, maybe we'll start over here this time. And we'll go this way. And again, we're just trying to see, is there a way of going over every bridge so that you go over every bridge once? Aye, so you can see, again, I've tried it again, but I've got stuck. Now I'm stuck on this side and I've missed out this bridge here. So that's the problem, okay? And that's the problem that I want you guys to solve. Is it possible to actually do this? And if it is, how can you do it? Now, in maths, what we like to do is we like to take a complex problem and make it a little bit more simple. So let's just have a look at a simpler way of drawing this situation. We could draw it like this. And when you think about it, there's only a few different things going on here. There's an island and another island. There's a sort of section above and there's a section below. And then there's seven bridges. So again, this might be, rather than be distracted by the actual map, we could just break it down. What are there? There's above, below, and then two islands. And then they're all joined up in these different ways. And we could even make it even simpler. Okay? We've broken it down. This is our first island. Okay? This is our second island. This is the above, and this is the below. And these lines here are the bridges. So there's a bridge that goes from the first island to above. There's actually two bridges that do that. There's a bridge from the second island to the above and to the below, etc., etc. So this is what we're going to be looking at. We're going to be looking at these kind of graphs, these special graphs that are made up of these big dots and these lines connecting them. So what we'll do is I'm going to give you a few definitions here. So first thing, these dots. These are called vertices. So that's the name for this big dot. We call this a vertex. So this particular problem, there are 1, 2, 3, 4 vertices. Okay, so we should probably come up with a name for the bridges or the lines, and we're going to call these edges. So this particular problem has 7 edges. So those would be the 7 bridges. And there's something else I want to share with you, and that's the idea of a degree. So a degree is how many edges a vertex has attached to it. So just to give you an example, this vertex here has a degree of 3 because it's got 1, 2, 3 edges coming out of it. Okay, if we look at this one over here, there are 1, 2, 3, 4, 5 edges coming out of it. So this vertex has a degree of 5. The degree of this one is 3. And finally, this one here is also 3. So those are the key words that I want you to sort of have. The idea of a vertex or vertices, the idea of an edge, and the idea of a degree. And the other word you've heard is traverse. And traverse is this game that we played. Can you draw this shape following the rule of you start at one point and you've got to try and draw the shape, but you're not allowed to retrace your steps. So let's try some examples. So here's a nice easy one to start. How many vertices does it have? 1, 2, 3, 4. How many of those vertices have an even degree? So let's just have a look. This one has a degree of 2. So does this one. So does this one. And so does this one. So actually, all 4 vertices have got an even degree, and none of them have an odd degree. Now, is it possible to traverse this? Well, yeah, you start here, go up, right, down, left. It's clearly possible to traverse. Okay, slightly harder question. Check. How many vertices does it have? It's got 1, 2, 3, 4, and 5. Okay, this has got a degree of 1. This has got a degree of 3. This one's got a degree of 2, 2, and 2. So how many even degree vertices does it have? It's got 1, 2, 3. And it's got 2 odd numbered vertices. Is this one possible? Well, yes, it is. We start here and we can go around. So I think if you were to start here, you'd have no problem traversing this shape. This would be quite an easy shape to draw, following our traversing rules of not lifting our pen off the paper. We'll look at a third one. Again, this is a bit more complex. How many vertices does it have? It's got 1, 2, 3, 4, 5, 6. This is an even number of 2. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2 for this bottom one. So actually, all 6 are even, so none of them are odd. Now, is this one possible? Okay, you'd have to try it a few times, okay, but you'll find that yes, it is. Okay, maybe we can look at one more example. So let's do question 4. Here we go. We've got a sort of strange looking shape here. How many vertices does it have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's got 1 degree. That's got 1, 2, 3. 2. This one's got 1, 2, 3. 2, 2, 1, 1, 2, 3, 4. Okay, so quite a lot of vertices here. There's 1, 2, 3, 4 even vertices, and there's, well, that's going to leave 4 odd vertices there as well. Is this one possible? Again, I'll invite you to get your pen and paper and have a go. Could you draw this one? Okay, so I'm going to have a go trying to draw it myself. And I'm stuck. And I'll let you know that this one isn't possible. Okay, so that's enough from me. We're going to have you guys go and have a go at an exercise now. So you're going to get something looking like this, and I'm going to get you to fill out a table just like this. Can you tell me how many vertices it's got? Can you tell me how many even degree vertices, how many odd, and can you work out whether it's possible to draw? Can you draw these shapes following that rule that we started with, just by starting at one point and just trying to draw without taking your pen off the sheet or retracing your steps. And what we're going to do is when you've done that sheet, this is your main task. Can you work out when a graph is traversable? So what properties, for example, the number of vertices, the number of even vertices, the number of odd vertices, does the graph need to have? So when is it that a graph is traversable? And I suppose the main question are the 7 bridges of Königsberg, is that traversable? Is that original problem solvable? And if so, how? And if not, why not? Okay, so that's the introductory video. Have a go at your task.